Imagine spending weeks, even months, orbiting our incredible planet. You've conducted groundbreaking experiments, witnessed breathtaking views, and lived in the ultimate high-tech laboratory. But eventually, every space mission must come to an end. The time arrives to leave the silent, vast emptiness of space and begin the incredible journey back to Earth. This isn't just a simple trip home. It's a meticulously planned, high-stakes operation. Returning from orbit is arguably one of the most challenging phases of any spaceflight. It requires immense precision, cutting-edge technology, and nerves of steel. This thrilling journey back to Earth is a testament to human ingenuity and courage. It's a complex dance between physics, engineering, and the raw power of nature. We're about to embark on an exciting exploration of how astronauts defy the odds and safely return to our home planet. Get ready to discover the incredible steps involved in this ultimate homecoming. It's a story of speed, fire, and controlled descent. From the moment they decide to leave orbit until their final landing, every second is critical. This journey is a true marvel of modern science and engineering. It's a testament to what humanity can achieve when we push the boundaries of possibility. The first crucial step in returning home is slowing down the spacecraft. Right now, it's hurtling around Earth at astonishing speeds, thousands of miles per hour. This incredible velocity keeps it in orbit, preventing it from falling back to the planet. To initiate the return, astronauts must perform what's known as a deorbit burn. This isn't a gentle tap, it's a powerful, controlled burst of thrust. Think of it like hitting the brakes in space, but on an epic scale. Small engines on the spacecraft fire in the direction of travel. This short, powerful burst of thrust acts against the spacecraft's orbital momentum. It's a precise maneuver, calculated down to the millisecond. The purpose of this burn is to reduce the spacecraft's speed just enough. It doesn't stop the vehicle entirely, but it subtly alters its trajectory. This slight reduction in velocity is the key to unlocking the path home. It initiates a controlled fall towards Earth, pulling the spacecraft out of its stable orbit. This is the gateway home, the critical moment when the return journey truly begins. Without this precise maneuver, the spacecraft would simply continue orbiting indefinitely. The deorbit burn is a testament to the incredible precision required in spaceflight. It's a delicate balance of power and control. This initial push sets the stage for the fiery descent that follows. It's a moment of no return, committing the spacecraft to its path back through the atmosphere. The astronauts are now on a one-way trip back to solid ground. This is where the real excitement begins. Once the deorbit burn is complete, the spacecraft begins its plunge through Earth's atmosphere. This is where the journey truly becomes a fiery dance. It's a spectacle of immense power and heat. As the spacecraft descends, it encounters the increasing density of Earth's air molecules. This creates incredible friction, a phenomenon that generates immense heat. The air in front of the spacecraft is compressed and superheated. This friction creates a blinding, fiery spectacle around the vehicle. The spacecraft glows intensely, surrounded by a plasma sheet. It truly appears like a blazing comet streaking across the sky. From the ground, if you were lucky enough to see it, it would look like a shooting star, but much larger and brighter. The temperatures generated during re-entry are astonishing, soaring to thousands of degrees Celsius. This extreme heat is a direct result of the spacecraft's immense speed. The air molecules are literally ripped apart by the force of the impact. This creates a superheated gas that envelops the entire vehicle. It's a controlled inferno, a deliberate plunge into a furnace. This fiery dance is a critical part of the return process. It's how the spacecraft shed the incredible speed it accumulated in orbit. Without this atmospheric braking, a safe landing would be impossible. The forces involved are immense, pushing the limits of engineering and human endurance. It's a breathtaking display of physics in action. This is where the heat shield becomes absolutely vital. Surviving the fiery dance of re-entry is only possible thanks to one of the most critical engineering marvels, the heat shield. This isn't just a piece of metal. It's an armor of fire, designed to protect the precious cargo within. Without it, the spacecraft and its occupants would simply vaporize. Heat shields are made of incredibly heat-resistant materials, often ablative. This means they are designed to burn away in a controlled manner. As the outer layers vaporize, they carry heat away from the spacecraft. This mechanism of protection is ingenious. The material absorbs and radiates away the intense heat generated by atmospheric friction. It sacrifices itself, layer by layer, to keep the interior cool. This sacrificial process ensures that the temperatures inside the spacecraft remain survivable for the astronauts. It's like a giant fiery hug that paradoxically keeps you cool and safe. The heat shield is the ultimate guardian. Different spacecraft use different types of heat shields, but their purpose is always the same: to dissipate extreme thermal energy. They are meticulously designed and tested to withstand the harshest conditions imaginable. The integrity of the heat shield is paramount for mission success. It's a testament to the brilliance of material science and aerospace engineering. This protective layer is the unsung hero of every return journey. It allows humanity to brave the inferno of reentry. The heat shield is a one-time use component, often charred and eroded after its fiery ordeal. Its sacrifice is a small price to pay for the safe return of our explorers. It truly is the armor of fire. Once the spacecraft has successfully navigated the fiery inferno of reentry, it has shed most of its orbital speed. However, it's still descending far too quickly for a safe landing. This is where the next critical step comes into play: parachute deployment. This occurs once the spacecraft has slowed down sufficiently, typically at a much lower altitude. A series of carefully orchestrated events begins, deploying multiple parachutes. First, smaller drogue parachutes deploy to stabilize and further slow the craft. Then the giant main canopies billow open, creating an enormous drag force. These massive parachutes act like giant brakes, dramatically increasing air resistance. They transform the rapid descent into a much more controlled and gentle fall. The effect is profound. The fiery descent changes into a graceful float. The spacecraft, once a blazing comet, now drifts serenely towards the Earth's surface. This stage is crucial for reducing the impact forces upon landing. The deployment sequence is precisely timed and redundant, ensuring reliability. Multiple parachutes are often used to distribute the load and provide backup. It's a beautiful display of aerodynamic engineering. From the ground, the sight of the parachutes blossoming open is a welcome sign. It signals that the most dangerous phases of the return journey are over. The astronauts are now truly floating to safety. This controlled descent is a stark contrast to the violent re-entry. It's a moment of relative calm before the final impact. The parachutes are the final act of braking before the ultimate touchdown. The final stage of the journey is the critical moment of landing. After the incredible speeds of orbit, the fiery re-entry, and the graceful parachute descent, the spacecraft must finally meet the Earth. There are two primary methods for this ultimate homecoming: splashdown or touchdown. One option is a splashdown, where the spacecraft lands in the vast ocean. This method has been historically used by many capsules, including Apollo and early Soyuz missions. The spacecraft, often designed to be buoyant, bobs on the waves. Recovery teams, including ships and helicopters, are strategically positioned to quickly reach the capsule. They retrieve the astronauts and the spacecraft from the water. It's a well-practiced operation, ensuring swift recovery. The other option is a touchdown, where the spacecraft lands gently on land. This method is characteristic of vehicles like the Space Shuttle or the Soyuz capsule's land-based landings. These spacecraft are designed for a softer, more precise ground impact. For Soyuz, retro rockets fire just before impact to cushion the landing. This ensures the spacecraft settles onto the ground with minimal force. It's a controlled, precise maneuver, often in remote, flat areas. Both splashdown and touchdown require immense precision in targeting. The landing site must be clear, safe, and accessible for recovery crews. Every detail is meticulously planned long before the mission begins. The choice of landing method depends on the spacecraft's design and mission profile. Each has its own advantages and challenges. Regardless of the method, the goal is always a safe and successful return. Its final impact, whether on water or land, signals the end of an extraordinary journey. It's the moment the astronauts are finally back on solid ground. The long voyage is complete. The safe landing of a spacecraft signals the triumphant end of an incredible journey. It's a moment of immense relief and celebration, not just for the astronauts, but for the countless individuals who made it possible. This return from the void of space is a profound achievement. It stands as a powerful testament to the power of science and human ingenuity. Every step, from the deorbit burn to the final landing, is a complex interplay of physics and engineering. It showcases humanity's ability to understand and harness the forces of nature. The bravery of the astronauts is undeniable as they willingly face the extreme challenges of spaceflight. Their courage and dedication inspire us all to reach for the stars. They are the pioneers pushing the boundaries of human exploration. Precision engineering is the backbone of every successful return. The meticulous design, rigorous testing, and flawless execution of each component are critical. It's a symphony of technology working in perfect harmony. The journey back to Earth is a vivid reminder that even the most challenging endeavors can be conquered. With ingenuity, perseverance, and a deep understanding of the universe, we can overcome seemingly insurmountable obstacles. It's a story of controlled chaos and ultimate success. From the fiery dance of reentry to the gentle parachute descent, it's a testament to human innovation. The return journey is as awe-inspiring as the launch itself. It closes the loop on humanity's incredible ventures into the cosmos. So, the next time you look up at the night sky, remember the thrilling journey back to Earth. It's a story of fire, speed, and the unwavering human spirit. It's a true triumph of science and exploration.